欢迎来到我们的突发事件节目。今天我们有3个重要新闻要分享给大家。首先，美国众议员马特·盖茨在前总统特朗普的庭审中现身支持，并使用了极右翼组织骄傲男孩的语言，这反映了特朗普支持者中的激进元素。其次，美国联邦存款保险公司 FDIC 主席马丁·格伦伯格因机构内部的有毒工作文化和骚扰问题，连续第2天在国会山被质询，并面临辞职的呼声。最后，中国国家主席习近平和俄罗斯总统普京在北京会晤，双方承诺在能源和金融领域加强合作，以应对西方制裁。请大家继续收看详细内容。首先来关注现场，习近平普京喝茶，中南海散步画面曝光。根据中国官媒新华社5月16日晚，国家主席习近平在北京中南海同俄罗斯总统普京举行小范围会晤。另一边，俄罗斯官方也在 X 平台上公开了习近平和普京在中南海内部散步聊天的视频，画面显示，除了习近平和普京，他们身边只有各自的随行翻译。另一段视频则显示，习近平和普京似乎是在人民大会堂走向拍照合影地点，在并排行进过程中，习近平对普京说的似乎是，到夏天了，现在开始收割小麦。另一段视频则显示，在普京座驾抵达人民大会堂前，中国一众高层领导丁薛祥、何立峰、张国清、华春莹、单怡琴走下台阶的画面，其中华春莹还走在单怡琴之前。美联社报道，美国众议员马特·盖茨在周四出席唐纳德·特朗普的庭审时，引用了极右翼骄傲男孩极端组织的语言，显示出支持特朗普的共和党候选人背后潜藏的激进分子力量。盖茨在社交媒体上发布了一张他和其他共和党议员站在特朗普身后的照片，并写道：“站在一旁，准备好，总统先生。”这种语言源自特朗普在2020年竞选辩论中对骄傲男孩的评论，当时他被问及是否会谴责白人至上主义者和民兵组织。尽管特朗普后来澄清自己并不认识骄傲男孩，但该组织的成员仍在社交媒体上庆祝他的言论，并在特朗普的竞选集会上频频出现。盖茨和其他保守派议员在法庭上支持特朗普，表明他们对这位前总统的坚定支持。环球邮报报道，美国联邦存款保险公司 FDIC 主席马丁·格伦伯格在国会山接受了第2天的质询。此前一份有关该机构有毒工作文化的报告引发了广泛关注。报告揭示了 FDIC 内部存在的敌对、虐待、不专业或不当行为的环境，并质疑格伦伯格是否有能力领导该机构进行文化转型。报告中列举了超过500起员工投诉，包括跟踪、骚扰、同性恋恐惧症等行为。共和党议员要求格伦伯格辞职，认为他未能有效处理这些问题。格伦伯格在证词中表示，对所有经历过性骚扰、歧视或其他不当行为的员工负全责，并深表歉意。民主党议员则呼吁格伦伯格进行改革，恢复公众和员工对 FDIC 的信心。美联社报道，联邦存款保险公司 FDIC 主席马丁·格伦伯格在国会山接受了第2天的质询。此前一份有关该机构有毒工作文化的报告引发了广泛关注。报告揭示了 FDIC 内部存在的敌对、虐待、不专业或不当行为的环境，并质疑格伦伯格是否有能力领导该机构进行文化转型。报告中列举了超过500起员工投诉，包括跟踪、骚扰、同性恋恐惧症等行为。共和党议员要求格伦伯格辞职，认为他未能有效处理这些问题。格伦伯格在证词中表示，对所有经历过性骚扰、歧视或其他不当行为的员工负全责，并深表歉意。民主党议员则呼吁格伦伯格进行改革，恢复公众和员工对 FDIC 的信心。参议员约翰·肯尼迪计划提出一项法案，延长 FDIC 员工就其在职期间遭受的虐待提起诉讼的诉讼时效。Telegraph 报道称，习近平在北京接待了普京，这次峰会展示了中俄之间日益紧密的关系。两国领导人在联合声明中明确表示，他们对美国主导的后冷战世界秩序持反感态度，认为美国的霸权行为破坏了战略平衡。声明中详细列举了美国的全球导弹防御系统、高精度非核武器的发展、对盟友的扩展和威慑，以及在欧洲和太平洋地区部署中短程武器等具体不满。尽管中俄之间存在许多分歧，但目前他们在地缘政治上站在同一阵营。此次峰会的议程显示，防务、安全和军事关系是核心话题，两国计划进行更多的联合军事演习。 此外，俄罗斯重申了对中国一国两制原则的支持，反对任何形式的台湾独立，并支持中国维护主权和领土完整的行动。South China Morning Post 报道，中国和俄罗斯在能源和金融领域承诺建立更紧密的合作关系，以从合作中获取更多利益。两国计划在石油、天然气、液化天然气、煤炭、电力等领域进一步合作，并确保跨境基础设施的稳定运行。双方还计划在可再生能源、氢能和碳市场等领域展开合作。去年，中俄双边贸易额创下2400亿美元的纪录，为在西方制裁下的俄罗斯提供了重要的经济生命线。为了减少西方制裁的影响，习近平和普京表示将增加双边贸易中的本币使用，改善金融基础设施。两国还将推动在金砖国家经济协会成员国之间使用本币结算、支付工具和平台。声明中提到，中俄将在民用航空、造船、汽车和设备制造、电子、冶金、铁矿石开采、化工和林业等领域加大合作力度。South China Morning Post 的另一篇文章详细列出了美国对14种中国出口商品的关税清单及其重要性。这些商品包括非锂离子电池、电动汽车、口罩、锂离子车用电池、非车用锂离子电池、医用手套、天然石墨、其他关键矿物、永磁体、半导体、暗桥起重机、太阳能电池、某些钢铁和铝制品以及注射器和针头。关税将在2024年至2026年间逐步提高，部分商品的关税将从0增加到25%甚至50%。这些商品在中美贸易中占据重要地位，例如2022年，中国向美国出口了价值10.1亿美元的锂离子车用电池，去年这一数字增长了34%至13.5亿美元。关税的增加可能对中美贸易产生显著影响，特别是在电动汽车和半导体等高科技领域。Telegraph 报道称，俄乌战争已持续超过2年，对两国经济产生了深远影响。战争通常被视为经济的对抗，损失领土和基础设施破坏，导致乌克兰经济大幅下滑。2022年 GDP 下降约30%。尽管如此，乌克兰在外部资金的帮助下逐渐恢复。2023年 GDP 增长近6%，预计2024年将增长4%。乌克兰的贸易赤字很大，部分原因是金属出口和谷物生产运输受到影响。通胀率从高峰的25%降至接近5%，但政府债务占 GDP 比率预计将升至100%。相比之下，俄罗斯经济虽然没有乌克兰那么直接受战争影响，但制裁和出口市场的丧失使其经济前景暗淡。俄罗斯的能源价格上涨和对西方市场的排斥使其经济增长前景变得不确定，未来几年可能面临重大经济挑战。Telegraph 还报道了法国指责阿塞拜疆在新喀里多尼亚煽动骚乱的事件。新喀里多尼亚位于澳大利亚和斐济之间，拥有世界第2大镍储量，但其加工厂由于印尼和中国的廉价竞争而濒临崩溃。骚乱导致5人死亡，包括2名宪兵。法国政府宣布紧急状态，并派遣警力和士兵平息骚乱。法国内政部长指责阿塞拜疆、中国和俄罗斯干涉新喀里多尼亚事务，称其为独裁政权。阿塞拜疆否认了这些指控，但与法国的关系在2020年和2023年阿塞拜疆与亚美尼亚的冲突后恶化。法国总统马克龙表示，法国在印太地区扮演平衡角色，但专家认为法国政府对新喀里多尼亚和平进程的处理不当是暴力升级的主要原因。Nikkei Asia 报道，中国电商巨头京东在经济低迷的情况下，通过降价和促销在第一季度超出预期，净收入同比增长7%至2600亿元人民币。京东 CEO 徐雷表示，提升用户体验促进了活跃用户和用户参与度的增长。京东通过降价和折扣保持竞争力，并扩大家电和电子产品的范围，响应政府鼓励家庭更换旧家电的倡议。京东还在直播领域进行尝试，推出了创始人刘强东的数字化身，吸引了大量观看。京东物流帮助中国品牌拓展海外市场，并计划在未来几年内回购30亿美元的股票。京东将在本月底庆祝纳斯达克上市10周年，总收入已从2013年的693亿元增长到去年的1.1万亿元。环球邮报报道，美国包裹递送巨头 UPS 已委托华尔街巨头高盛管理其在美国和加拿大的434亿美元养老金资产。 这一合作标志着资产管理业务的重要性日益增加。高盛也希望通过减少对波动性较大的交易和投资银行业务的依赖来实现多元化。UPS 的投资关系官 PJ Guido 表示，这决定将有助于 UPS 更专注于其核心业务，同时增加监督和专业知识，惠及退休人员。UPS 的内部投资管理团队将加入高盛在亚特兰大的办公室，继续为养老金计划提供服务。团队过渡预计将在第3季度完成，不会改变参与者的福利或计划管理方式。卫报探讨了羞耻感是否能使人变得更好。古代中国哲学家孔子和其他人认为，羞耻感并非全然负面，而是引导人们走向更好自我的重要工具。羞耻感通常源于我们对自身缺陷的认知，并且有助于我们修正道德标准与行为之间的差距。孟子、荀子等儒家学者强调，羞耻感是通过自我培养而来的情感，而不是他人强加的。儒家认为，真正的羞耻感来自违反自身价值观，而非外在的财富或地位等表面因素。通过控制和理解羞耻感，我们可以抵制不合理的社会标准，推动个人道德成长。卫报报道，道琼斯工业平均指数首次突破4万点，得益于美国企业强劲的季度业绩和市场对美联储降息的预期。自2020年春季以来，道指已翻倍。当时世界卫生组织宣布新冠疫情为全球大流行，导致企业关闭和供应链问题，引发通货膨胀。尽管面临高企的物价和美联储的加息，美国经济表现出显著的复苏迹象。通胀率从2022年6月的高峰 9% 以上降至今年4月的 3.4%。道指的上涨也受到人工智能创新和成员公司如沃尔玛等发布的积极财报推动。然而，尽管股市和就业市场表现强劲，消费者信心却降至6个月低点，这给拜登政府在即将到来的选举中带来了挑战。Telegraph 报道，乔·拜登已经2次向唐纳德·特朗普提出辩论邀请，并且特朗普也已经同意。拜登巧妙地利用了这个机会，发布了一段视频，挑衅特朗普来辩论，并表示自己愿意进行2次辩论。这一策略似乎是拜登为自己争取了至少3个月的休息时间。通常选举辩论会在几周内进行3场，而不是像这样在半年内进行2场。拜登的策略显示出他目前在一些关键摇摆州的民调落后，他希望通过辩论来重燃公众对选举的关注。特朗普同意这样的时间表也让人感到意外，因为这样反而给了拜登更多的休息时间，掩盖了他所谓的衰老问题。The Independent 报道，英国最具吸引力的单身汉之一，第7代西敏公爵休·格罗夫纳将于下个月在柴郡的切斯特大教堂与奥利维亚·格雷斯·亨森结婚。尽管拥有伦敦梅菲尔一半的地产，格罗夫纳还是决定离开伦敦，搬到柴郡与新婚妻子一起生活。格罗夫纳是英国最富有的人之一，与王室关系密切，国王查尔斯甚至是他的教父。格罗夫纳在2016年继承父亲的爵位和地产后，成为了英国第3富有的人。他的未婚妻奥利维亚·亨森也有王室背景，两人通过朋友认识，并共同致力于环保事业。美联社报道，宾夕法尼亚州下一任检察长的竞选将以国家政治主题为主。民主党候选人尤金·德帕斯夸莱和共和党候选人大卫·桑迪将在11月的选举中展开对决。德帕斯夸莱强调保护选举和堕胎权，而桑迪则将芬太尼危机视为首要问题，并批评拜登的移民政策。两位候选人都表示会捍卫宾夕法尼亚州的堕胎法律，并在打击毒品犯罪方面有相似的立场。德帕斯夸莱认为应该接受法院对2020年选举结果的裁决，而桑迪则在选举舞弊问题上保持中立，仅表示他不质疑拜登的胜利。谢谢您的收看。上面播报的内容是六度团队推荐的全球专业媒体、智库、政府机构和行业专家的最新报道、分析简报。更详细的内容，请大家去这些媒体、智库的网站阅读。这些内容并不一定反映六度简报的立场，亦不能作为任何决策的建议。六度团队由专业媒体人、学者、科学家组成的独立新型媒体，大家可以根据自己的专业要求订阅各种简报。网址是6dobrief.com， 您在世界任何地方都可以通过电邮收到六度简报。
Washington and Brussels are in the midst of a policy funk over the possibility that China's industrial policies could do to the market for legacy chips, or what some in the industry prefer to refer to as mature node semiconductors, something similar to what happened with photovoltaics, PVs, over the past decade. and potentially to electrical vehicles, EVs, over the next decade. Namely, fears are rising that there could be overcapacity in semiconductors of the mature variety, a fear partly animated by seeing how Chinese subsidies on steel and PVs have affected global markets, generating a desire to be proactive in trying to address future potential areas of overcapacity. And to be sure, Beijing has provided subsidies across the semiconductor supply chain, including to mature node manufacturing firms. The core concern is driven by China's current plan to build mature node fabs and the conclusion that this will result in overcapacity. The reality is more complex though, because mature node semiconductors, it turns out, are very different from either PVs or EVs. In fact, this may not be the overcapacity problem anyone is looking for. Title 1, The Market Globally and in China. Let's explore why concerns may be misplaced by looking first at the global market structure for mature semiconductor production, and then at China specifically. The industry prefers the term mature node to legacy chips in discussing the topic. Mature nodes are typically regarded as those produced at nodes at the 28 nanometers, nm, level or above, the definition that the Commerce Department as part of CHIPS Act language and Bureau of Industry and Security, BIS, has used in requesting input from U.S. companies about their use of China-origin semiconductors. Semiconductors produced with these more mature processes are typically made at facilities where the equipment costs have been fully amortized, but they involve much lower profit margins than the most advanced semiconductors. These include central processing units, CPUs, graphics processing units, GPUs, and other application-specific integrated circuits, ASICs, that are used in smartphones, for training AI models, or for other applications demanding high levels of performance and low levels of power consumption. Typically, memory chips are not included under the term mature, because most memory is produced and sold at more advanced nodes, where capacity, speed, and density are at a premium. There are 4 critical basic elements of the market for mature node semiconductors that are relevant to the debate regarding overcapacity. First, the term mature semiconductors covers a range of different types of chips, each with its own supply and demand dynamics. These include both specific types of semiconductors, including logic, power, radio frequency, and mixed analog and digital semiconductors, and mature semiconductors used for specific types of end uses, such as automobiles, robotics, drones, industrial automation, aerospace, and other industries. Hence, there is no single market for legacy semiconductors, as there is for products like EVs and PVs. This makes overcapacity an inappropriate lens through which to view the issue. For example, aggregating capacities for fabs in a particular country based on process node does not account for the diversity of applications and requirements that semiconductors manufactured at a particular node actually cover. Second, most mature semiconductor node capacity globally resides with so-called integrated device manufacturers, IDMs, while in China the capacity for mature node production is dominated by companies engaged in foundry services, which includes a high degree of specialization. Foundries build semiconductors based on designs provided by their customers. These are contracted levels of production and depend on market demand as determined by the customer of the foundry, not the foundry itself. Company-designed semiconductors are closely aligned with the demand in their particular sector, and they seek to carefully balance supply and demand. In fact, their business models are designed to avoid overcapacity, meaning overproduction that has tended to be more common with IDMs. Foundries tend to be highly specialized, and often each fab facility that is operated by a company will be set up to address a very specific client product. Hence, aggregating capacity numbers at specific nodes does not indicate the supply and demand function for specific types of semiconductors produced at those nodes. In China, based on the author's discussion with industry officials, the expansion of manufacturing capacity at mature nodes by 2030 will be dominated by foundries. In 2023, the foundry/IDM split was roughly 60/40 and is projected to be 64/36 in 2030. Third, because it is difficult for foundries, which for mature node semiconductors operate on very thin profit margins, to rapidly switch production lines. Foundries and customers prefer to engage in long-term contract arrangements to lock in supply for a specific type of semiconductor. This holds, in particular, for industries with long product life cycles and high levels of safety requirements necessitating stringent qualification of product quality and reliability, such as medical devices and automotive applications. Fourth, and perhaps most important, is the often overlooked or misunderstood concept within the industry of economic overcapacity. This refers to the idea that the global industry actually views a certain amount of excess supply as desirable and critical to smoothing out anticipated and common perturbations in supply and demand. Some of these risks include tool downtime, which is unpredictable, natural disasters, such as the Fukushima earthquake, which affected front-end manufacturing and material suppliers, the winter freeze in Texas that impacted Samsung, and other accidents such as fires at key facilities that have occurred over the past several years. some in the industry hold that an optimal level of overproduction is around 15 to 20%. Even after the major chip shortages during the pandemic, there continue to be rolling shortages for some mature nodes, and the health of the overall system requires some level of economic overcapacity. Finally, focusing on things like fab utilization rates may not be a good proxy for considering where there might be overcapacity that could translate into the potential for dumping, which is defined as exporting products at prices lower than they are sold in the domestic market. Fabs involve a lot of complex tools operating at high speed, and require a lot of maintenance. For example, utilization rates can vary from 70 to 90%, depending on the node and critically, on demand. During the chip shortages during the pandemic, some fabs were working at 99% utilization rate. They were running tools too hard, too fast, and for too long, a condition which is not normal or desirable. But the circumstances required it. But this situation did not lead to overcapacity or dumping. Only if a fab is, say, running at 99 to 100% utilization for 2 to 3 years without a broader global supply chain crisis should government officials be worried about a high utilization rate leading to potential dumping. Title 2, China and the worries about overcapacity. Understanding what is driving the expansion of China's foundry capacity is critical to getting at the issue of whether overcapacity is likely to happen in mature semiconductor production. A number of factors at play highlight the difficulty of a situation where Chinese companies, either foundries or IDMs, could flood the market and drive down prices, disrupting markets. Currently, Chinese firms account for a growing share of global front-end manufacturing for mature semiconductors. This market share differs by node, with around 27% for 28 to 65 nanometers process node production, falling to around 20% for 90 to 180 nanometers. If the current announced fab capacity expansions are realized over the next 2 to 5 years, then by 2030 Chinese companies may hold a larger share of global capacity, but it is hard to be sure since there will also be major capacity expansions for both mature and advanced node semiconductors in the United States, Japan, Taiwan, South Korea, and Europe. There are 3 reasons why overcapacity concerns are either exaggerated or misunderstood as emanating uniquely from China. First, production expansion goals are different. The goal for Chinese firms expanding capacity, such as SMIC, Huahong, Grace, Huali, CN, and many others, is to supply primarily domestic demand. With China still importing a huge majority of its domestic semiconductor consumption needs, there are commercial drivers for expanding domestic capacity. U.S. export controls have also accelerated this trend, both by preventing companies like SMIC from being able to focus on advanced node production and by spurring the Chinese government to encourage companies in China to seek domestic alternatives to foreign suppliers for both hardware and software across a range of government organizations and industrial sectors. SMIC, for example, has gone from having 60% of its production for foreign customers 5 years ago to nearly 80% of capacity now used for domestic customers. Close to 80% of Huahong production is also for domestic customers. This is very different from PVs, for example, where the target from the beginning was the export market. Second, demand is key. Most of the commentary on China and the potential for overcapacity in mature semiconductors focuses on the supply side, that is, extrapolating the capacity expansion that will result when all the mature node fabs under construction are completed within the next 3 to 5 years. But the key question for semiconductors is demand. Domestic demand in China remains high and will only increase substantially through 2030. Projections of demand based on specific sectoral applications, servers, PCs, mobile devices, autos, industrial sectors, etc. matched against capacity at specific process nodes, 28, 40, 65, 90, 180 nanometers, provide a way to assess whether and when signs of overcapacity could become real. One non-public industry study seen by the author, for example, showed that by 2030, assuming all of the announced fabs in China are actually built and operating by 2030, domestic capacity will be able to cover around 90% of domestic demand, including Chinese OEMs, and foreign OEMs with factories in China. This number was around 37% in 2020. Third, the benefits of government support are not starting to show yet. Concern about China and mature node semiconductor centers on how the potential benefits of Chinese government subsidies could accrue to Chinese foundries and the potential for this to contribute to overcapacity. In assessing this issue, it is important to note that for leading Chinese foundries such as SMIC and Huahong, their margins, capex, and depreciation compare favorably with industry averages. With the global semiconductor industry just emerging from a major downturn, for example, all foundries, with the notable exception of TSMC production at advanced nodes for products like NVIDIA GPUs, are experiencing low utilization rates, are trimming prices to gain orders, building fabs with high levels of depreciation, and experiencing low margins. Again, SMIC and Huahong's financial performance levels are generally consistent with industry averages, so it is difficult to say that SMIC is cutting prices because the firm is receiving government subsidies or that they have a higher margin because of government subsidies. In addition, even if under some circumstances Chinese foundries could offer below-market prices for mature node semiconductors, the cost of these semiconductors is already relatively low, so there would be little incentive for domestic or foreign companies to boost ordering from China-based foundries. This also holds because semiconductors are intermediate products, purchased by original equipment manufacturers, OEMs, unlike EVs or PVs. In addition, domestic OEMs are not likely to be responsive to slightly lower prices offered by SMIC or to Chinese government exhortations to source semiconductors domestically. Most, but not all, Chinese OEMs are market-driven and globally competitive, and they are also interested in other factors such as reliability and quality. Foreign OEMs may be responsive to lower prices and government-driven local sourcing requirements, as they must compete with Chinese semiconductor firms and local OEMs. Here the "in China for China" approach is a trend for foreign players. In addition, the quality of mature node semiconductors from Chinese foundries for specific end uses varies considerably. Products from these foundries are getting more competitive for some consumer electronics applications but remain significantly less reliable for end-use applications such as automobiles. Here, foreign firms like NXP, Infineon, Renesas, and Texas Instruments will continue to hold dominant positions in the China market. Chinese domestic firms are becoming more competitive in some auto industry semiconductor segments, such as powertrains, but lag significantly in other areas like ADAS platforms. Finally, while Chinese foundries do lower prices in ways that put pressure on non-China-based foundries, PSMC, for example, does compete directly with Chinese foundries in areas like specialty memory and display ICs. Lower prices are not only a direct result of government subsidies but are more likely to result from things like better cost control. In addition, some fabless firms and OEMs welcome lower prices and diversified manufacturing sources driven by healthy competition. Title 3, Looking Ahead, US and EU Concerns about China. With officials in both the US and European Union taking a hard look at the potential for overcapacity in producing mature nodes and attempting to craft policy responses, it is important for policymakers to understand the complexities of semiconductor supply and demand in general. Determining if there is actually a problem requires understanding Chinese companies' position in global and domestic value chains in particular. The U.S. Commerce Department in the first quarter of 2024 surveyed around 100 U.S. companies to determine their dependence on Chinese firms for mature semiconductors. The dependence issue is tightly coupled to the overcapacity concerns, as U.S. officials are concerned that overcapacity could lead to greater dependence, and hence vulnerability of companies to disruptions in mature node supply chains. The situation is also complicated by the large number of finished products that are assembled in China by foreign firms, including U.S. companies that incorporate mature semiconductors. U.S. companies import few individual semiconductors, but rather products containing one or many mature semiconductors that could originate in China, both from domestic and foreign foundries operating in China. Because of U.S. export controls and the growing pressure in China for certain government and state-owned enterprise-based supply chains to reduce the quantity of foreign-sourced semiconductors, the proportion of China-origin mature semiconductors winding up in IT products manufactured by foreign companies in China is likely to rise. For example, new guidelines on government procurement for PCs, laptops, and servers released in a draft last August were followed by implementing documents in late December by the Ministry of Finance, MOF, and Ministry of Industry and Information Technology, MIIT. They were accompanied by a whitelist of domestically approved secure and controllable processors issued by the China Information Technology Security Evaluation Center, NITSEC, a technology evaluation organization closely associated with China's security services. The NITSEC whitelist includes processors from Huawei, Fidium, Luxon, and Zhaoxing. The first three companies are on the U.S. Commerce Department's entity list. The procurement efforts in these types of guidelines have typically been governed by internal documents, marking this as what appears to be a rare instance where such guidelines are being made public. The effort is part of a process known internally to China as Xinchuang, meaning Information Technology Application Innovation. The new guideline was characterized by a local government official as the first national, detailed, and clear instruction for promoting Xinchuang. In addition, SOEs have been instructed by the State-Owned Asset Supervision and Administration Commission, SASAC, to work towards a 2027 date to transition to domestic suppliers for all technology requirements, presumably meaning both hardware and software for products such as computers, laptops, and servers, and likely more and more mature semiconductors will be included on whitelists, as domestic production increases and the levels of quality also improve. Given this process, which can also be seen as protectionist and a non-market practice that has clearly generated considerable concern with the IT sector broadly, the domestic demand curves in key application areas for mature node semiconductors are only set to rise, a process also undercutting the idea that the domestic semiconductor production will reach some level of overcapacity anytime soon. This will not stop governments from being concerned about the potential for overcapacity, given past experiences with PVs and the current concern over EVs. But semiconductors really are different. That said, the scale of the subsidies provided to Chinese semiconductor manufacturers and the sheer scale of the growth of domestic mature node capacity are significant and have generated valid concerns within the semiconductor industry and in Western capitals. In assessing the implications of this massive expansion in China, it is important to remember that companies outside of China in the mature node sector are not standing still. Global Foundries, and Taiwan's TSMC and PSMC, for example, are increasing production capacity for mature nodes in the US, Singapore, Japan, Germany, and India, providing a diversified mature node footprint to balance some of China's natural growth. For Chinese companies to win in the mature node semiconductor space by 2030 requires both easing of geopolitical tensions between the US and China and the ability of Chinese OEMs to deliver a cost advantage. Under this rosy scenario, for example for the auto sector, Chinese OEMs building EVs and other related IT products that use mature node semiconductors gain significant global market share and demonstrate that using mature semiconductor node products from Chinese companies provides significant cost advantages and drives increasing adoption by incumbent OEMs. This would mean that China-origin mature node semiconductors are used in products sold in both China and internationally. The opposite scenario is basically the status quo. Chinese OEMs continue to gain domestic market share but fail to gain traction outside China, as geopolitical tensions override any cost advantage. Here, China-based mature node semiconductor companies gain a share only among Chinese OEMs, and global OEMs continue to prefer products from incumbent mature node semiconductor producers. Hence, the bifurcation between the China market and the rest of the world seems more likely than China creating overcapacity that swamps global markets. Available estimates of the balance of capacity and demand to 2030 suggest that even with the significant growth in domestic capacity, satisfying the huge increase in domestic demand will remain the focus of Chinese foundries. Any policy response related to concerns about overcapacity in mature node semiconductors must take into account all of the above factors. In determining if there are valid and sufficient reasons to believe that by 2030 there will be anything resembling overcapacity, governments must be very careful and fully understand the complexities of the industry, on both the supply and demand sides of the equation, which are considerably different from EVs and PVs. Policymakers in the US and the EU should draw on industry expertise to understand the directionality of markets for each technology node and seek industry input on particularly difficult areas to get reliable data, such as demand projections to 2030. Without a thorough understanding of the industry, supply and demand, commercial considerations, regional and geopolitically driven commercial preferences, and technology roadmaps, it will be impossible to determine whether there is, in fact, a problem and to determine what measures to take in response.